Gentlemen, this is the video for questions 1 and 2 in the new AP packet number 2. So we're going to take a look at questions 1 and 2 today. So for the first question, we were given this function f of x equals the square root of 25 minus x squared, which we know is a semicircle that exists between -5 and 5. In A, it asks us to find f prime of x. So if we take a look at what I did here in A, I figured out the derivative by using the chain rule by first rewriting the square root of 25 minus x squared as 25 minus x squared to the 1/2 power. I sent the 1/2 to the front, kept the inside piece, lowered the exponent by a power of 1, and then multiplied by the derivative of the inside, which we know is -2x. Here the 2 and the 1/2 cancel out to leave us with the -x. And since this has a negative exponent, we're going to send it to the bottom and make the square root positive. So we end up getting that our derivative is -x over the square root of 25 minus x squared. Okay, for B, we have to write the equation for a tangent line at x equals -3. Since we already found the derivative back in A, we're going to use this information in order to find the slope of the tangent line at -3. So you'll see here that I plugged -3 in for my x, and when I did that, I ended up getting that my derivative at -3 should be equal to 3/4, which is the slope of my tangent line along with the slope of my curve at that point. All right, then the next thing that I'm going to want to do is figure out what the b value is by substituting in my x and my y. I know that my x is -3, and you can get your corresponding y by plugging back into the original. So if I substitute -3 back into the original, I know it got a little bit cut off here, but of course the answer is equal to 4. So now I have the x and the y value, I have my slope that I got earlier on here, which is 3/4, and now I can solve for my b. If I plug in and solve for b, I end up getting that my b value is 25/4, which means the equation of my tangent line is y equals 3/4 x plus 25/4. For letter C, it asked, is the function g of x continuous at x equals -3? Use the definition of continuity to explain your answer. So we know that the definition of continuity involves the fact that there's 3 criteria that have to be met. The function's limit has to exist, the defined value has to exist, and the defined value and the limit have to be the same. So the first thing is we need to establish if the limit exists in the first place. So you'll notice here I set up the limit as x approaches -3 from the left of f of x, because f of x is the function we're using from the left, and the limit as x approaches -3 of x plus 7, which is the function from the right. So what I'm going to then do is figure out what the value is from the limit as x approaches -3 from the left by using f of x, which we know is the square root of 25 minus x squared, and then you plugging in the limit as x approaches -3 from the right, which is the right function, which is x plus 7. So the left would be this guy, the right would be from this guy. If I plug in -3, we know from part B that that's going to equal 4. So right here, we know that g of -3 is equal to 4. And then here, if I plug -3 in for x plus 7, I end up getting 4. Since both values are equal to 4, then we know that the limit does in fact exist. We don't know that g of -3 is equal to 4. And so the conclusion is we know that g of x is in fact continuous, because the limit as x approaches -3 of g of x is in fact equal to g of -3. And again, we have to make the reference to g because it's talking about is g continuous, not the fact that it's f. Realize that g is now a piecewise function, and the question that's not up for debate is whether f is continuous. It's whether g is continuous at x equals -3. All right, our next question is D. It says find the value of the integral from 0 to 5 of x times the square root of 25 minus x squared. All right, since we see that this is a composite function, we're going to shoot for u substitution. Remember that the u is always the inside part of the function, so in this case it's 25 minus x squared. Our d would be the derivative of whatever's on the inside. In this case, that would be -2x dx. I see that already here I have an x, but I need a -2. So what I'm going to do is multiply the inside right here by -2, but to keep it balanced, I'm going to multiply the outside by -1/2. Essentially what I'm doing is multiplying by a +1, which is allowed to happen in mathematics. So if you take a look at what I have now here, I can make a substitution in terms of u and du based upon the substitutions that I created. I know that -2x dx collectively is du. I know that 25 minus x squared is my u. It's going to be raised to the 1/2 power, and the -1/2 is going to come along for the ride. I also know that the bounds have to be different because these are in terms of x and our bounds need to be in terms of u. So here I know that x is equal to 0, so if I substitute x equals 0 in for my u right here, I get that u is equal to 25. And if I substitute my upper bound of 5 in for my x, I end up getting that my u here is 0. So you'll notice what I did is, I know the outside is negative 1/2, but if I switch the bounds and negate this, I end up getting that now it's equal to a positive half, and the bounds are now going to go from 0 to 25, which is the correct order. And that's going to go from 0 to 25 of u to the 1/2 to u. Making the integration, I'm going to increase the exponent by a power of 1, which gives me 3/2, and then I'm going to divide by that power, which ends up being the multiplying by its reciprocal, which is 2/3. The 1/2 is going to come along for the ride, so that means the 2's will now cancel, and I'm left with u to the 3/2 power divided by 3, evaluating from u equals 25 to u equals 0. Doing upper bound minus lower bound, I get this as my answer. Realize that on the AP exam, you could leave the answer like this if you don't want to go any further, because they do say that answers don't have to be simplified. But if you want to go one step further, remember it's power over root. The square root of 25 is equal to 5. 5 cubed ends up being 125. 125 over 3. If you take a look over here on the left, this is the breakdown for the point allocations for this problem. 2 points was awarded for the derivative. 2 points were awarded for part B. 1 point was the slope. 1 point was the actual tangent line. In C, 1 point was awarded for using one-sided limits. The other point was the justification. In D, 2 points were awarded for the correct antiderivative. 1 point was awarded for the correct answer. All right, let's take a look at question number 2. So question number 2, we were given a function, a second, or keep in mind, the first derivative for W. It says here the twice differentiable function W models the volume of the water in the reservoir, where W of T is measured in gigaliters per day. T is measured in days. The above is the values for W prime of T. From 0 to 30. At T equals 30, the reservoir contains 125 gigaliters of water. All right, let's go over a couple different things, folks. First thing is that this last sentence is the initial condition, so we're going to have to somehow use that in our problem. Next thing I want to point out is that they're talking about this as gigaliters per day, so it's the derivative, but it's quite obvious because they're actually using the prime symbol here. So it's one instance where it's clearly the derivative, right? Which means WT is the function and W prime of T is the derivative. I also wanted to point out that any mention of differentiability also implies continuity, so that's important. All right, in A it says, use a tangent line approximation to W at T equals 30 to predict the amount of water W of T in gigaliters in the reservoir at T equals 32. Show the computation that leads to results. All right, first things first, we want to always say that the tangent line is y equals mx plus b. I'm going to make a small amendment because there is no x and there is no y in this problem. There's only t and w, so I made the modification to the tangent line. The first thing we're going to always want to find on our tangent line is the slope, and we know that the slope comes from the derivative. So if I find the derivative of w specifically at t equals 30, because remember it's the tangent line at 30, we know that w prime of 30 is equal to 0.5. So now I know the slope of my tangent line, so that's 0.5. The next thing we need to figure out is what is the y-intercept, the b value. Well, I know that 0.5 is my slope. We know that t is equal to 30 the moment that w is 125. That comes from the initial condition. Half of 30 is 15, so if I bring over the 15, I get that b is equal to 110. So now I know my tangent line is w equals 0.5t plus 110. I could then use the t equals 32, which is where they want us to find approximation, and replace that in for the t to end up getting that our w at 32 is 126 gigaliters. For B, the question wants us to know, using a left-Riemann sum with 3 subintervals in the data of the table, approximate the integral from 0 to 30 of w prime of t. Use this approximation to estimate the volume of the water in gigaliters in the reservoir at t equals 0. Show the computations that lead to your result. All right, so if we're going to approximate this using 3 subintervals, I created my 3 spots. Remember, Riemann deals with rectangles, so we need to find out the area of the rectangles. Realize that each of these subintervals difference is the base of the rectangle, so the first base is 10, the second base is 12, and the third base is 8. Since we're performing a left Riemann sum, we're going to grab the left value of the function at the first rectangle. So it's going to be 10 times 0.6, 12 times 0.7, and 8 times 1. If I crunch all these numbers, by the way, you could have left the answer just like this because remember they said that answers don't need to be simplified, but if you were to crunch it, you'd end up getting 22.4 gigaliters. Now, this tells me that after 30 days, there's 22.4 gigaliters, but we know that from the beginning, I should say, that's my bad, at t equals 30 rather, we know there's 125 gigaliters. So if I want to know how much gigaliters was at the beginning, then what I would need to do is subtract. I know that there was 22 4 gigaliters that occurred between 0 and 35 days, and after the 30 days, it's recorded there's 125 gigaliters. So if I subtract the 22.4 that I got from here, that must mean there was 102.6 gigaliters from the very beginning. All right, for C, it says explain why there must be at least one value t other than t equals 10, where w prime of t is equal to 0.7 gigaliters. Now, this phrasing indicates that we should be using either the intermediate value theorem or the mean value theorem. This one's going to be a little bit tricky in the fact that you're seeing, okay, it says derivative, so I'm probably going to go with mean value theorem. The problem is, folks, that this is a table of the derivative and we're looking at the derivative. It's not like we're looking at the table of the derivative and they want us to find the second derivative. That would mean I need to use the mean value theorem. So really, if it's the derivative and we're finding values of the derivative, we're going to be using the intermediate value theorem. Okay, so I put here as a note, since w prime of t is given and not asking for w double prime of t, then we'll be using the intermediate value theorem. I know that sounds confusing, but since we're given the derivative and we're asking about the derivative, we're going to use the values for the intermediate value theorem. So it says here that at t equals 10, we already know that it's 0.7, but it's saying other than that one instance, is there another case where this happens? And the answer is yes. In fact, if you look at the time t equals 22, we know that w prime is equal to 1, and that at t equals 30, w prime is 0.5. That means somewhere along the way, from 1 to 0.5, it had to have been a value of 0.7. And we know that this is going to be the case because that value is intermediate of these two numbers right here. So remember, with the intermediate value theorem, we have to know that the function is continuous. I know the function is continuous because it's stated earlier on that we know that it's twice differentiable. So that must mean that if automatically it's differentiable, then it's got to be continuous. So what I wrote here is that since w prime of t is continuous on the interval from 0 to 30, then there must exist a value of t between 22 and 30, where w prime of t is equal to 0.7 by the intermediate value theorem, where 0.5 is less than or equal to the w prime of t value we're looking for, which is equal to 1. So notice that this value is truly intermediate of these two numbers. All right, that takes care of C. For D, it says the equation A equals 0.3 w to the 2/3 power gives a relationship between area A and square kilometers and the surface area of the reservoir. The volume of the water W of T in gigaliters is in the reservoir. Find the instantaneous rate of change of A in square kilometers per day with respect to T at T equals 30. Folks, this underlined sentence part right here clearly indicates it's the change in A over time, which is dA over dt, which means we're going to be doing a related rate. So you'll notice here that I did the derivative with respect to time. So I have dA over dt is equal to, if I multiply 2/3 by 3/10, I get 1/5. W decrease the exponent by a power of 1 to the so it's the negative 1/3 power, and then times it by the derivative of W, which would be dW over dt. Remember that this is related rates so that everything is respect to time. Since we're looking for dA over dt, I'm going to substitute all the known information in. 1/5 comes along for the ride. The W value, so when t is equal to 30, remember from the initial condition, W is equal to 125. So this gets rewritten as 1 over the cube root of 125. So if it's got a negative exponent, it gets sent to the bottom. The 1/3 power is the cube root. dW over dt is the derivative of W at t equals 30, which we know comes from the chart, and that's equal to 0.5 or 1/2. If I plug all these values in, we end up getting 1/5 times, this is also 1/5 times 1/2, which we end up getting collectively 1 over 50. Since it's dA over dt, realize that A is measured in square kilometers and time is measured in days. So our answer ends up being 1 over 50 square kilometers per day. You'll notice over here to the left, this is the point breakdown. 1 point was awarded for the tangent value with the approximation. 3 points were awarded for the Riemann sum, the value, and the correct answer. 2 points were awarded for using the intermediate value theorem with the proper justification. In D, there was 3 points. 2 points was awarded for the correct derivative, and 1 point was for the final answer. All right, folks, I hope you found this video to be helpful, and I will get to you with the video for questions 3 and 4 tomorrow. Have a great day.